Right, good afternoon, ladies and gentlemen, and welcome to this week's Quick Bites webinar from J2code. As you can see, my name is Paul Wright, and I'm currently teaching computing at two Hull primary schools just north of the Humber, and working part-time for J2code. With me today is Alistair, also from J2code. Alistair's manning the chat line, so if you have any questions, please direct them to Alistair, who will either answer them there and then, or maybe save them for the Q&A session we set aside for the end of the webinar. Okay, so today's agenda is all about your first steps in making a game in j2code. And it'll be 15 minutes or thereabouts, and we're going to cover those and have a look at some examples that I have done with pupils in the schools that I'm working in. So if you are new to J2E and j2code, let's start with how you get there. When you log on to your launch page, you will be able to get it from either that block there, that menu item, or the tile. The tile will almost certainly be in a different place because I move mine around from time to time, but it will be there. So that's how you get to j2code, and then you will be presented with this screen. JIT is the early years key stage 1 coding application. Logo is a text-based coding platform, and there's a virtual microbit, but we are going to look at j2code Visual, which is a block-based coding program similar to Scratch and Blockly and Crumble Controller and many others out there that use blocks to help you code. So if you are new, here it is. We'll go to j2code and off to Visual. And when it starts up, you are presented with this screen, a penguin and white. At Christmas and Halloween, they changed the penguin, they being j2e, they painted the penguin to something more seasonal and topical, but that's how it's going to be for most of it. So let's start with how you can create a background. So the way is you click on the penguin and then the penguin again, and we'll go down to backgrounds, and J2E have provided us with quite a number of backgrounds for you to use. So you just need to click on it and click OK, and that becomes your background in your scene. Now, I'm very keen on getting the pupils to click here and rename, because later on, as we'll see, if they're renamed, it's easy to spot which one you are coding. So we'll imaginatively call it scene. So what we need now is another sprite. So a nice little bit of technical vocabulary. They are called sprites. So we'll add in one here. Again, we'll go penguin, penguin, and we'll go down to the space theme, and we'll just go and get, that'll do. Pop that in, and you can resize that with the slider or these buttons. They don't be the right size for you. That one will flip it round and flip it back again. And what's quite important is this direction button here, because you can decide which way is forward. It's less critical for these, but we'll have a look in a minute when we get a sprite off the web, why that's important. So I shall rename that. Vehicle, and that'll do nicely. And then we can pick that up, we can put it where we like to start. So let's quickly click on here, and it's penguin, penguin. Now your other option for getting pictures is every time you do a search or save a picture in your My Files in J2E, it'll just hang on to it until you delete it. So you can just go and get any picture. You can see I acquired thousands in the course. So I'm going to click that, making for a slightly bizarre game, but that just shows you how you can get a picture that you have previously saved, and then I would rename it if we were carrying on. And then the final option is penguin, penguin, and you can have a web search, and all you need to do is to, obviously I've done a few before, so I'll just cat and press enter, and it will go off and find. So there we go. And then we are presented with a cat, which I can resize. So ways of getting backgrounds and images into a j2e code scene, either the built-in ones, any that you've got, or off the web. Now, I don't need that anymore, so I think I'll just lose that file. I won't bother to save it. No, I'll leave it there for the time being. So let's have a look now about one that's partly done and how we can move a sprite around the screen. And the way, so if I just start this game, you can see that I've coded the robot to go up and down and left and right. Okay, this is based on a text that the children used where the robots spread seeds and kill trees, and we decided that we'd code it to fit that. One of the children said, yeah, that's fine, and said, but when robots don't travel like that, it's not realistic. So we can see here the robot is using these keys, and you get those from events. You can either use the arrow keys, which are pre-coded for you, or you can use this block, drag it out onto the page, and if you click there, you can decide that any key will be the one that the children need to press. So I can just press that, drag it to the bin. I don't need it at the moment. So you can see here that forward and backward are fine, but left and right don't work. So what I'm going to do is I'm going to whip those out, and I'm going to replace those with the change X by gimmick here. So if I press the D key now, then the robot moves in a way that's probably more familiar to pupils and possibly teachers who play that sort of game. So obviously what I need to do now is to get it to go the opposite direction, and that would be changing X by -10. So now step 1 in my game, I have a sprite that moves. So let's have a look what happens when it hits the tree. There we go. You'll see it's changed from healthy tree to dead tree. And we did that by looking here. Now, normally your sprites will just go along the top, and each sprite will just have one, what they call a costume. So if I click here, that is the robot. If we look at the tree and look at its costumes, I've got 2. I searched for that off the internet and just added it like I did previously. Then I put it in a second time. I clicked on here and I added the costume in. But what I did with this one was I clicked on the paint button and I just decorated it. So let's just, see if I just put a few red splotches on. And if I go back now, you'll see that I've changed it. So I named them healthy tree and dead tree. And if we come back and look at the coding, obviously when the game starts, it starts as healthy tree, tells us to wait until we're touching the robot. And it's important to point out to the children, they need to make sure that they're coding the right thing, because we want the tree to change, not the background or the robot. And let's just have a look one more time. The come across, up we come. Robot touches tree, switch costumes, tree is dead. Okay, cheerful little bit. So that's one example of how we can move our robots with sprites and how we can affect a change when 2 sprites meet. Another way we can move a sprite around the screen is to have a look at one. Again, this is linked to a text that the pupils were doing. I've taken the map off just for clarity, so it's easier to see this one. So we can see here that they were called marvels. They're called Rumble Star, and marvels are things that they have to collect. So some of the children decided that what they wanted in their game was to have the balloon drive and collect marbles. And one of the things was, how can we make it move around the screen? You can see here that we've told it to move forward by 5. That can be changed if it's too fast or too slow. We need to do it forever. Okay, and this turn right by 22 was just to get the sprite. Well, let's just disable it and see what happens. If we disable that and then run it, it will go forward until it gets on the edge, and then it'll bounce and it'll come back. But of course, it's just going to go straight up and down the screen, which is not what we want. So we just throw in a turn to get it off that path, and then when it hits it, it'll bounce off at random angles. Okay, so that's a way of getting a sprite to move around on its own without being driven. Okay, so let's have a look at the another game here, and I'm going to show that's my snowboarding game. So here I'll just start it off and you will see what happens. So the poles slide down. We started this in the Winter Olympics, and you can see here, look at the snowboarder, the costume changes as I press the left and right arrow keys, so it looked like it's going. And right at the start, I mentioned perpetual motion. Well, this is it. We could have made the game so that we could code the snowboarder to go up the screen, but we felt that would end very quickly. So we have got these poles dropping down, and you look, if you get hit by a pole, then he says something and he goes back to the start. Okay, so let's just have a look at how that game was created. So the snowboarder, you can see here, when the right key is pressed, we've asked it to switch a costume. Here we are, we have two costumes, snowboard right and snowboard left. And come back to the game. So that takes care of that. So when you press the left arrow key, you go to snowboard left and snowboard right. And this is where a lot of the work is done for the snowboarder. So I'm just going to take one of these out just to break it down a bit. And what I like to do with the pupils is get them to talk it through in English. I think if they can't explain what they want to happen in English, then they're not really going to be able to code it. So we've got the poles to fall. We'll look at that in a second. So here, if it touches pole 4, which is one of these, obviously, we want it to say ouch for half a second. And then the penalty is the snowboarder glides back. So we tell it to glide to these coordinates, which is, there we are, somewhere about there. Okay, glides back to about there and then starts again. And we've just done that for each of the poles. Now, it's really important to mention a forever do loop to the pupils, and this is a good example. So I've just flipped to a file here. So, you know, we've got the giraffe. We want it to point towards the mouse pointer. There it is. Click on start. It points to the mouse pointer. It's done its job. But look, I really want it to follow the mouse pointer, and it's not doing that. And it's a good example of how, you know, computers and coding are great, but it's not doing what we want. So it's done its job. It's looked once and it's kind of packed up. We want, if we put the forever do loop round, then the giraffe will forever point at that mouse pointer until we get it to stop. Okay, so if you look at the snowboarder game again, if we didn't do that, if we just disable that forever do loop and we'll start the game, well, quite clearly the pole has hit the snowboarder, but nothing has happened. What's happened really is that as soon as we start the game, the coding has checked, you know, is the snowboarder touching a pole? No, right, job done, I'm kind of packing in. That's why we need to enable everything goes around a forever do loop, or inside a forever do loop. And now we'll go. Here we go. Okay. Ouch, back. So there is the penalty in that game. Okay, and the last thing we need to do is to come back to the perpetual motion. We'll just break this down. So pole number 1. So I've told it to go to. Now, this is the block that I used here in the motion. You can use glide or you can use go to. Glide is a smooth one. Go to is instant. The default is these. Okay, but what I've done is that I've taken those out and I've gone to these operators and I want it to go here to a random integer. So on the x-axis, anywhere between 1 and 100, and the y, I'll just 210 because I want it on the y-axis to start round about there. Okay, so there's a lot of little teaching points you can go there. You can remind them about the forever do loop. If you want to change the speed, you can change the speed and make it go slower or quicker by telling it how far you want it to move each time. And this business of randomness. So of each of the 4 poles, I'm just going to throw that away now. So each of the 4 poles, I think I've got one to sort of go between here, you know, so they all basically fall between the width on the page and they don't cross over each other. And I've just changed the numbers slightly. So that was 14090. Poll 2 will go 9060. You can see what I've done there. Just move them slightly across the page so that they fall. Although it's random, they'll fall within a certain parameters. So if you can, rewatch this video sometime and pause occasionally, they, I think, are some of the key concepts that you can get your children to create a game with. Now, in year 5 and 6, you can take that further with doing scores and lives, but that's for another video, and certainly couldn't get that into a 15-minute video. So I hope that's been useful for you. This webinar will be published here fairly soon. If you just go to j2code.com news, you'll see the quick bites, and you'll see all the quick bites that have previously been recorded and uploaded, and then over on this side you will see more upcoming webinars. Okay, so I'm just going to ask Alistair if anybody has any questions. Alistair?
Hi Paul, thanks ever so much. Folks that are on the chat here, if you would like to ask a question by using your audio, just pop a message on the chat to say unmute me, and I'm very happy to unmute you. So if you could like to ask a question at all, I'll unmute you. If not, you could ask your question on the chat. But whilst people are writing there, I'd just like to say that is a really great example, not only of how to create games, how to lead into the steps to designing games with the children. I really liked, Paul, the way that you'd got the Forever Do explanation down. That's such a simple way to create an effective understanding with children of how to use the Forever Do function. Really good stuff.
Thank you. I've been doing it for years. And that giraffe idea stumbled in about 3 or 4 weeks ago. I thought, why did I never think of that one before? There we are.
That's for a whole different webinar, is why the giraffe. Okay, so if you have any questions, do feel free to put them in the chat, or I could happily unmute you if you would like to. I'll just give a couple of minutes for people to get busy typing if they have any questions. Don't forget, as Paul suggested, that there are a whole bunch of other upcoming sessions on the Quick Bites, and all of the previous ones, the wonderful sessions that Paul has been recording so far, are all available there on the Quick Bites place on the website for your viewing delectation at any point in time, so you can watch again whenever you like. Okay, well, there's no questions coming through on the chat, so we'd just like to say thank you so much to Paul. Thank you to our guests for joining us today. It's really great to have you with us, and I look forward to seeing you on the next session next week.
Okay, thank you very much. Thank you for your time, and enjoy the rest of your evening. Thank you.